So on numbers 12 and 13, we're trying to prove we have similar triangles. I've gone ahead and drawn on a coordinate plane. To prove that they are similar, we could do this with angle, which is really tricky when you're not working with necessarily like parallel lines where you can actually like measure the angles. So a lot of times what you might have to do is look at proportional sides. Now I will say this here, if you look at this one here, this is going up 1 over 2, and then this one's going over 2 down 1. Those are opposite reciprocal slopes. So we do know that actually this is a right angle right in there. So we can use that to help simplify and save ourselves some time. Now what you can do then is you can prove that you have similar triangles by proving that, I guess you could technically do parallel lines here. Parallel lines would have the same slope. So if you look here, we have our same slope. Let's try it. Up 1 over 1, 2, 3, and then we have up 1 over 1, 2, 3. So yeah, this would actually be parallel. So if these are parallel, then the corresponding angles here would actually be congruent, and that's actually a little faster. So now we could say that triangle ADE is similar to triangle ABC by AA similarity. And that would be, again, because our slopes here, since they're the same, the slopes gave us parallel lines, and parallel lines gave us congruent corresponding angles. So what you could do to write this up is you could say, since AD is perpendicular to AE, because the slopes are opposite reciprocal, and DE is parallel to BC because the slopes are the same, and therefore angle ADE is congruent to angle ABC because of the because of the corresponding angles postulate. These triangles are similar. All right, let's look at number 13. So number 13, right off the bat, I see that I could go ahead and say I've got this side here, this angle is congruent to this angle because of vertical angles. I might as well write that. So angle SRT is congruent to angle VRU because vertical angles are congruent. And let's go ahead and look at our sides here. Our sides, this right here is up 1 over 2, so let's find SR. If it's up 1, we're going to have 1 squared plus 2 squared. That's the Pythagorean theorem squared. So this is a right triangle, 1 squared plus 2 squared. And that's 1 plus 4, which is 5, equals C squared. So C is equal to square root of 5. Now let's go ahead and do RU. RU is up 2 over 1, 2, 3, 4. So we've got 2 squared plus 4 squared equals C squared, which is 4 plus 16, which is 20. So then we can take the square root of 20 would be our C. So C equals square root of 20. So I'm going to mark these, square root of 5, square root of 20. And then let's go ahead and get these sides here. This is 3 units long, and then this is 1, 2, 3, 4, 5, 6 units. So let's see what we've got. We want to see how does square root of 5 compare to square root of 20? And how does that compare when we look at like 3 and 6? So let's see if I've set this up right. So if we do 3 times the square root of 20 equals 6 square root of 5, and I simplify 3 square root of 20, that gives me 6 square root of 5 is equal to 6 square root of 5. Those are the same. So the sides are proportional. So sides are proportional. Thus, the triangles are similar by SAS similarity.